So we're on page 101, and the problems that we're going to do in 6, we're going to do J and N. Okay, in 7, we're going to do T and X, and in 8, we're going to do parts N, part O, and part P. So here we have 4 root 2 plus 3 root 5, and here we have 4 root 2 minus 3 root 5. So we have the perfect square term a plus b times a minus b. If you let the a equal this part, it's the same over here. So it's a, this is the b, and this is the b. So we have a plus b times a minus b. And when we use the FOIL method here, the first times the first gives us 4 root 2 times 4 root 2. And then this outer term, minus 3 root 5 times 4 root 2, minus 3 root 5 times 4 root 2 is the outer term. Then the inner is the same thing but positive, 3 root 5 times 4 root 2. And the last times the last is minus 3 root 5 times 3 root 5. And okay, we take, in this case, the outer and the inner terms cancel. So this is canceled by this term. The first term is 16 times the square root of 2 squared, which is 16 times 2, which is 32 right here. And the last is 3 times 3 is 9. Square root of 5 times square root of 5 is square root of 25, which is 5. 9 times 5 is 45. So we have 32 minus 45 is 13. Now, when you do this problem, if you realize that the inner and outer cancel, you can just write this part in and this part in. You don't need to do this as long as you're sure that the inner and outer cancel. How do you know? Well, this term and this term have to be identical, and this term and this term have to be identical. And if that's the case, you don't have to worry about the inner and outer terms as long as one is plus and one is minus. Now, here we have 3 terms in this case and 3 terms in that case. So what we're going to do is break this down and first of all multiply root 2 times each one of these. So that's the first part of the problem. Then the next part of the problem is we're going to multiply root 3, including the sign, by each one of these. And finally, we're going to multiply root 5 by each of the terms in the second bracket. So minus root 5 times this, this, and this. So we get minus 5 root 2 minus root 5 minus root 2. We multiply this times this. We get minus 5 minus root 5 times root 2. Then we multiply the minus 5 times this term. We get minus root 5 times root 3. And finally multiply this times this. So let's go over that again. We're going to multiply this term by each of these terms in the second bracket. Then we're going to multiply this by each of these terms in the second bracket. And finally we're going to multiply this by each of the terms in the second bracket. So we're going to have a total of 9 terms. So let's take a look. Root 2 times root 2. If we go down over here, Here are all the 9 terms, root 2 times root 2, root 2 times root 3, and root 2 times root 5. So that will be the first term in the first brackets multiplied by the second brackets. Then we're going to take the root 3, again multiply it by the root 2, and we're going to multiply it by the root 3 right here. And finally we're going to multiply it by root 5. So you can see here the root 2, and the root 2 changes to root 3, and root 3. And finally, the last term is going to be all negatives because you're multiplying by minus root 5. So you're going to multiply minus root 5 times root 2, minus root 5 times root 3, and minus root 5 times root 5. So we have this over here. So you can see that in this case, when we do this, we check that you have 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice here you have root 2, root 3, root 5, root 2, root 3, root 5, root 2, root 3, root 5. So root 2 times root 2 is 2. The square root of 2 times the square root of 3 is root 6. Square root of 2 times square root of 5 is root 10. Square root of 3 times square root of 2 is root 6. Square root of 3 times square root of 3 is 3. Square root of 3 times square root of 5 is square root of 15. Now the last 3 terms, minus root 5 times minus root 2 is minus root 10. And this one will give us minus root 15, and this will give us minus 5. And what happens is you can see that you've got 2 plus 3 is 5, minus 5 is 0. So the numbers, the integers, sum to 0. 2 plus 3 is 5, minus 5 is 0. Now you can see that the root 10, plus root 10, and minus root 10 cancel. The plus root 15 and the minus root 15 cancel. So that all you're left with is root 6 plus root 6 gives you 2 root 6. So we go back again, remember what you've got to do. You take the first term, multiply it by each of the terms in the second bracket. Then you're going to take this one, multiply it by each of the terms, and you're going to take this one, including the sign, times this. This will give you a total of 9. And then it's just a matter of collecting like terms. Here we're asked to rationalize the denominator and simplify it. So you can see that you have 25 square root of 3 minus 4 root 2 over 7 root 3 minus 5 root 2. The conjugate of the denominator is 7 root 3 plus 5 root 2. And we're going to multiply the top and bottom by this. If we multiply the top and bottom by the same thing, we're not changing anything. This over this is 1. So now what I do is I take the first times the first, the 25 times the 7 gives me 175. The square root of 3 times the square root of 3 gives me 3. And now when I multiply 5, the outer term here, 5 times 25, I get 125. And the square root of 3 times the square root of 2 is the square root of 6. The inner one is minus 4 times 7, which is 28, and root 2 times root 3 is root 6, so I'm minus 28 root 6. And the last here is minus 4 times plus 5 is minus 20. Square root of 2 times square root of 2 is 2. Minus 20 times 2 gives me minus 40. Okay, the numerator is the first times the first, which is 49. 7 times 7 is 49. Square root of 3 times square root of 3 is 3. The last is going to be minus 5 times plus 5, which is minus 25. Square root of 2 is 2. So now I add 525. 3 times 175 is 525. I subtract 40, I get 485. 125 minus 28 root 6. 125 root 6 minus 28 root 6 becomes 97 root 6. And 147. 3 times 49 is 147. 25 times 2 is 50. 147 minus 50 is 97. So now I can break this up into 485 over 97. And I can break the 97 root 6 over 97 into this part here. 97 goes into 485 5 times. The 97 cancels here, and I'm left with 5 square root of 6. Multiply the, in this case, rationalize the denominator. So if I want to rationalize the denominator here, I take the whole denominator. There's two terms. This is one term. This is the other term. And I change it to a positive sign, a sign between them. Okay, I multiply the top and bottom by this, so I'm not changing anything. So 1 times this is this. The first times the first means that I'm going to multiply what's in the square root sign by what's in the square root of sign, and that gives me x plus 1 squared, square root of, and minus 1 times plus 1 gives me minus 1. Now, when I simplify this part of the denominator, the square root of x plus 1 squared is x plus 1. So I'm just going to change this to this, and then I've got the minus 1. X plus 1 minus 1 gives me x, and the numerator stays the same. Okay, here we have 4x to the 3 halves, y to the 5 halves, xy to the 1 half. So the first thing I'm going to do is rewrite the problem here. Here it's totally rewritten. Now instead of 4, I'm going to write 2 squared. The x is going to stay the same. The power is this 3 halves here, and I'm not changing this. So the only thing is I'm changing what's in the bracket into 2 squared x. And I'm removing this bracket here. This is x to the 1. X to the 1 times a half is x to the half, and y raised to the power 1 times a half is y to the half. So I just removed the brackets from here. And now what I'm going to do is I'm leaving the 2 squared to the 3 halves here, and I'm going to take x to the 3 halves right here. This is x raised to the power 1 times 3 halves gives me x to the 3 halves. Oops, right here. X to the 3 halves. Right here. I'm right here. And this y to the 5 halves is right here. And the denominator doesn't change. So the only thing I've done is remove this from the bracket, and I've changed x raised to the power 3 halves to x raised to the 3 halves here. Now I can operate on this 2 squared to the 3 halves. The 2's cancel, and I'm left with 2 cubed. So the 2 on the numerator here and the 2 on the denominator here in the powers cancel each other, and I'm left with 2 cubed. I have x to the 3 halves. I'm going to bring this up to the denominator, and that's why I have minus a half. And y to the 5 halves minus the 1/2 on the denominator. So all I'm doing in going from here to here is three things. I'm saying 2 squared to the 3/2 is 2 cubed, and then I'm bringing this x 1/2 up to the numerator and making it minus here. I'm bringing this y 1/2 from the denominator up to the numerator, and here it's minus 1/2. So 3/2 minus 1/2 is just 1. It's 2 over 2, which is 1. 5/2 minus 1/2 is 4/2, which is 2. So x is to the power 1 and y is to the power 2. 2 cubed is 8. So essentially what I've done is operate with the number 4 raised to the power 3/2, changed that, and then collected the x terms and the y terms, so they're all under one term. They're no longer separated numerator, denominator. Okay, now we're on page 101.80, and here instead I'm rewriting the problem here. So this problem is this problem here. Instead of 27, I'm going to write 3 cubed. Instead of 64, I'm going to write 4 cubed. So I can easily work with this here, operating on these. So I take this out of the bracket, big bracket, and I get 3 cubed raised to the power 1/3. X to the minus 3 raised to the power 1/3. 4 cubed raised to the power 1/3. Y to the minus 3 raised to the power 1/3. So I'm essentially operating, multiplying this times this, then this times that, this times that, and that times that. So operating on each one of the components within the brackets. So 3 cancels, and I get 3 to the minus 1. The minus 3 and the minus 1 gives me plus 3 divided by 3 gives me 1, and I don't put it in here. I haven't put it in. You can if you want, x to the 1. The 3 here and the 3 here cancel, and I have 4 to the minus 1. This is minus 3 times minus 1/3, which is y to the plus 1 raised to the power plus 1. So that's the same as this. Now I just bring 3 to the minus 1 down to the denominator here to make it 3 to the plus 1, and 4 to the minus 1, bring it up here to make it 4 to the plus 1. And that's because I don't want to, I do not want to leave the problem with negative exponents here. Okay, now we're going to do 4 to the 5ths to the power minus 3/5 minus 8 to the 6th to the power 1/3. Now, 4 to the 5ths to the minus 3/5, you can see the 5s will cancel, and I have 4 to the minus 3. Minus 8 to the 6th power will give me 8 to the 6th because it's an even number. So minus 8 to the 6th power is the same as writing plus 8 to the 6th power. That's the only difference going from here to here. Now, 4 to the minus 3 is 1 over 4 cubed. 6 divided by 3 is 2 with a minus sign here. It's minus 2. So this is 1 over 8 squared. So in changing this, I made it over this, and in changing this, I made it into this. Now I have 1 over 64. 1 over 8 squared is also 1 over 64 equals 0. And that completes page 101.